Have you ever stopped to wonder how your computer can show you a photograph? The answer is this: your computer doesn't see a picture, it just reads numbers. Every digital picture is made of millions of tiny squares called pixels. Each pixel has a specific color, and that color is represented by a number. As you might know, we have different color systems such as CMYK, Pantone, and RGB, which is the most common and widely used system, especially for screens and digital displays. In this system, a color is a combination of three numbers, one each for the intensity of red, green, and blue. Your computer stores all of these numbers in its native language, binary code. Imagine a very simple 10 by 10 pixel image. That's just 100 pixels in total. For your computer to process this picture, it has to read the color code for every single pixel and send it to the display. Let's look at a few examples. A pixel that's pure black has no color at all, so its code is 000. A pixel that's pure white is a mix of all colors at their full intensity, so its code is 255, 255, and 255. And what about a vibrant color, like a vivid hot pink? That might be something like 255, 20, 147. Let's consider pure red. The numerical code is 25500. These numbers make sense to the computer like this: 255 in binary, 8 ones, 0 in binary, 8 zeros, and 0 in binary, 8 zeros.
We are small, but we work together.
Yeah, without me, you'd have a hole in the picture.
So just to display one single red pixel, your computer has to process a 24-bit string of ones and zeros. Now multiply that by the 100 pixels in our tiny picture. That's a total of 2,400 bits of data that the CPU has to read, translate, and send, all for a single small image. Now you should know why file sizes are that different. It's because the file size is directly related to the total number of pixels. We know that each pixel is represented by a 24-bit string of ones and zeros. So it's obvious, the more pixels you have, the more of these long strings of code your computer has to save. Fewer pixels mean fewer lines of code and naturally a much smaller file.
All this work for a tiny image?
Now for the really mind-blowing part. A video is nothing more than a series of still images shown in rapid succession. A standard video plays at 24 frames per second. Just let's calculate for fun. Imagine you are watching a Full HD video. In this case, your computer has to display 24 frames every single second. Each frame contains nearly 2 million pixels. This means your computer's processor has to handle a mind-boggling 15 million pixels per second. If you watch just 1 minute of video, that number climbs to over 3 billion pixels.
What?
This insane volume of processing is handled by your computer processors, CPU, and sometimes GPU.
3 billion? I need a nap.
Relax. I eat billions for breakfast.
So the next time you look at a photo or a video, remember you are not just seeing an image. You are watching an endless stream of ones and zeros being brilliantly transformed into a visual masterpiece by the magic of your CPU and GPU.